So the question has been asked to review the assignment. The assignment, no, not this one. The assignment for module 3 about network segmentation. And so what I'd like to do Yep. Can everyone see my screen?
Oh,
Yeah.
nice.
No, I don't see your screen.
You don't see your screen, my screen yet. Okay. All right. So the question was asked, can I explain the assignment? And let's take each one. We'll explain a little more about each of these assignments.
Yeah. For
And-
me, I want quite know what to do, kind of. You know.
Okay. So what we're going to do is change the due date to 11:59 p.m. today. Okay. Network segmentation. When we break up a network into smaller segments or smaller subnets, this is called segmentation or subnetting. The most common method used to perform this segmentation is something called CIDR, classless internet domain routing. Normally, in the beginning days of the internet, when an organization needed network addresses, the network address ranges were assigned by class. They were assigned in 3 different tiers: really big, medium-sized organizations, and smaller organizations. So the class A subnets would include millions of addresses. The class B assignments would include tens of thousands of addresses. And the smallest class C assignments would include up to 256 address assignments. Now, we've already learned that in each network, you need a network identity, which is usually the very first address of a network range, a range of addresses. And we've learned that what's typical in most networks, though not mandatory, it's not required, but it's practiced, is that the very next IP address in the range is used for the gateway assignment. And this network gateway number is usually configured on the port of a router. Okay, so we've kind of dabbled with that in our packet tracer screens. How are we doing so far? Does anyone have any questions about what I've explained so far?
No questions.
Okay. Good afternoon, Joseph. How are you?
I'm good. How are you?
Good. So we're reviewing the assignments. And so essentially what we've done is extended this to 11:59 p.m. So it's a best practice to take, instead of having one big messy network, what you want to do in order to manage the traffic efficiently and to provide for better security and to allow better management, right? There's all sorts of reasons. You break it up into smaller segments. The method to use that is called CIDR. CIDR is one of 3 adaptions, 3 methods or adaptions that came about when the world ran out of public IP addresses. And we do have private internal address ranges that you can translate between public and private. That's natting. But one of the things I wanted you to do was to use these commands so that you could catch a view of some of the segmenting in your own network environment here in the territory, okay? So if you take a command prompt, right? And you enter one of these commands, I'm going to give you an option to help you capture. So we're going to add something to these commands, and I'm going to demonstrate the first one. If I go to a command prompt, or if I'm on a Linux machine or in a Mac, what we're talking about is a terminal shell, right? So those of you that mess with Linux or a Mac environment, you can open up the utilities and go to a terminal environment. It's a command prompt, right? So you're gonna, if you don't have command prompt showing, you just start to type in CMD, and then you can load this. Now, can everybody see my screen?
Yes.
Okay.
Yes.
Now it's best when you're running commands from a command prompt to actually run as administrator. You shouldn't have to do that for these commands. There are occasions when you run commands from the command prompt where you want to, so I'm just giving you a little extra here. If we go here and then we type in CMD, you can run as administrator, right? And that prompt looks a little different. It says administrator, and that means you can execute those commands. But we're going to try to execute these commands differently without administrative privileges, because it used to be you could get basic network information from anybody who's on the screen, right? So when you talk about support staff, you know, tech support, you call them and they say, hey, can you open this window? Can you type in this command? And one thing that they do in networking oftentimes is they ask you to type in this command, ipconfig. In its simplest form, it's going to show you what your locally assigned IP address is, the subnet mask, and then the gateway, right? So that tech support can figure out, okay, are you operating on an internal private environment? So you're networking with the internet through NAT. Are you doing something different, right? Here's a neat trick. I have a folder on my C drive. Can everybody see my screen?
Yes, we can see it.
So I'm in Windows Explorer right now, and I have a lot of junk on my system, right? I just have too much. But if I go into my C drive, I have a temp folder, and this is actually really helpful. Okay, because I can do stuff like this. And so what I can do is clear a little workspace here in my temp folder. And actually, I'm going to change this here. So it's what I want to do is I want to capture the output of this command to this folder. So I can work with command output in one of two ways. I can view it real time in the window on the console as it's described. And if I actually if I hit my up arrow key, I can repeat the command. You might know that just hitting your up arrow key is really helpful. There are additional options for the ipconfig, and this one produces an awful lot more information, right? So now it gives me the MAC address, the physical address on layer 2 of that interface. And so there's all this rich information for networking. One thing I want to do at times is not just have it on the screen, because it runs off the screen, right? I have a command and then the information runs past the window, and I'm expected to submit this for an assignment or something, or to do some tech support or assessment. It's too much information. So I'm going to hit my up arrow key again. If I redirect this with the right arrow and I use the drive letter C and backslash and then temp, and then I give it a decent name like ipconfig, and then underscore, what's today's date, right? 4-6-2022. .txt, right? Is everybody with me?
Yes.
Yes.
So I'm using the backslash, not the forward slash. I'm putting it in the temp folder. I want this output to be redirected from the screen into this text document. So when I hit enter, boom. It's going to sit and it's going to think for a minute. And I'm wondering if that name caused a problem. Yeah, it seems to be, maybe this naming convention was a little too much. I'm going to hit Control C to break this. And I'm going to hit the up arrow a couple of times here. Let's try it a simpler, let's just try it a ipconfig.txt. All right, everybody with me? Oh yeah, that's it. It was the naming convention that was troublesome. So one of the things that you gotta pick up on is that sometimes in the command environment, you have to stay within certain criteria. You have to stay within certain boundaries or guidelines when you name a file. And I think this was a problem. So if I go to my temp folder, now I have ipconfig, right? Does that look familiar?
Yeah.
Yes.
So let's get back to our assignment and talk about the segmented network, right? Because some of you are going, all right, Kentop already. I have this rather complex command. And what I'm telling it to do is to ping a system that's sitting on 146.226.249.120. That's actually a system that's sitting on the campus. It's in my office. And it should be running. Should be running right now. I'm going to stop sharing. I want to verify something. I just want to verify that I do have a system with the 120 address. And I'm not showing you this because why? I have all kinds of other addresses. Yeah, you know what? I'm beginning to understand that they're all right. So if I just want to ping the address, I'm not going to get a good result. But if I use the other command, what I'm doing is pinging all of the networks between here and there and getting detail back.
That'd be the tracer one, right?
Yeah, the trace route and the path ping.
Yeah,
And-
that one had me confused because the other one wasn't, it was giving me just 2 and tracer gave me like 10, but in between it would say timed out, request timed out.
Right. Okay. Let me check something here real quick. Okay. Hang on just a moment. I'm going to pause the recording and I need your help to remember to restart the again. And I'm going to share the screen. So the 2 commands that I gave you are supposed to work whether the system you're pinging, what the system you're connecting to exists or not. And I'm going to explain in just a moment. So on our campus, we have a whole series of different real and virtual systems that are configured. And over the spring break, we had to overhaul and then rebuild some of our virtual systems. What path ping and trace RT do is it sets a series of it's called ICMP. So this is a internet protocol that's used to test for connectivity between network hosts and along the way with network hosts. And in particular, path ping and trace route kind of perform the same function, but the way they do it and the information they return is a little different. And in a Mac environment, you're going to use trace route, the command trace route with that IP address, and you're not going to worry about those other switches instead of trace RT. RT is an abbreviation for route, okay? So what happens is that we use the ping command and it starts to work its way out from my machine, which is sitting on, where is my machine? My machine on the public network is sitting on an address 208.49.194.161. That's my public IP address, my laptop internal address that's translated into this as I'm on the internet. So my 192.168. something, right? 192.168.1.17. It's translated into this public IP address, this single public IP address. And then it starts working its way toward the host that's connected on the campus. And so as it starts to run this series of pings, it's using this ICMP service, ICMP protocol, and it's collecting information, and it's supposed to list this information down the screen. And some of you have seen that. If it hits network security equipment, sometimes those reconnaissance pings, right? So these are, and let's take it a step further. I keep saying ping, and it's related to the IP protocol. Can everybody see my screen here?
Yes.
Yes.
Okay, so here's another host, and what we're going to do is change this a little bit in a minute. We're going to change the assignment so that you ping either 101 or 102. But one thing I want to tell you is there's firewalls, and we've talked about firewalls, haven't we? Haven't we said the client, you have a client firewall, it's a software-based firewall, and then you have like hardware firewalls in some cases. You know what? I'm going to go back to this picture. So in Windows, when you're running Windows on a laptop or a PC, you have a software-based firewall, and it prevents inbound network connections that you're not supposed to be receiving. And that's its main function. It's to try to keep the trash out when you're connected to a network. And it tends to work in a inbound one-way direction. Now you can set up a firewall so that it works both with inbound traffic and with outbound traffic. So the word is ingress. You have inbound traffic and data on a device, then you have outbound traffic. If I want to change, if I want to allow an app or a feature to go through this, like ICMP, I have to scroll down and try to find something that talks about ping. And you see other software and applications, right? You have remote assistance, remote desktop. I wouldn't be able to do what I'm doing right now if this wasn't allowed. I don't see a specific entry for ICMP. So I want to check something else. I'll go to advanced settings and I'll go to inbound rules, and I want to make sure that this host 101 is actually going to accept that kind of traffic, right? Can everybody see this stuff that talks about multicast listener and then neighbor discovery? See where it says neighbor discovery ICMP 6?
Yes.
Okay. So that's when you're working with IP version 6, that's something that needs to be allowed. This thing right here, ICMP echo request, and this is version 4. That's what I'm using right now. I'm not using version 6. In the territory, we don't have any internet service providers that allow this. Do you see a green check mark next to this?
No.
Yeah, I don't see any either. And this is for the IP version 6, these two, and then this one. So what I'm going to do is I'm going to select this and enable the rule and enable the rule. Now, what does that let me do? I should be able to ping this. .249 dot, what was it, 101? That was it, wasn't it? No, I was supposed to be able to see a result. Let's do a little troubleshooting. I'm going to turn the firewall off for a second. Okay. I'm not going to leave it that way, but I'm going to turn the firewall off. And I'm going to try pinging this thing again. Oh, okay. So there's another rule that, maybe I have to restart 101. Maybe there's a service issue that needs to refresh. I just turned on the rule to allow ICMP. If I turn off the firewall, then now I can ping, okay? So the ICMP service sends a packet out from my machine here on my internet service provider connection, right? I'm using broadband VI, and it sends that packet out to 101. So instead of using 120, I'm going to change this right now. And we're going to say we'll use 101, because by the time we finish walking through this, we want to make sure it's working. Another thing that's happening too is that some of our service providers are implementing more and different security because of some of the stuff that's happening. I know it sounds like a far stretch, but Russia and the Ukraine, my son has a wireless smart outlet in his house, and he works in cybersecurity for the department. He works for a company that serves a lot of Department of Defense customers. And his home was attacked over the weekend on the network. And they did some things to flood his outlets, his electrical outlets, with packets so that they would shut down. And we actually have a video of this. It's really cool. So I'm going to try to put that out there a little bit. But normally this is very predictable. And normally when you enable the rule, it just plain works. So if I restore, turn my Windows Defender on again, and I try to repeat the same command on my system. Yep, it says it can't find its way. So let's find the rule that we need to change this so that we can get it to work right. We turned on these rules, but I'm gonna come down a little further. Ah, Here's more echo requests. All right, so let's talk about ICMP. ICMP is a protocol that's used with the IP network suite of protocols. It's used with them. And it's a great troubleshooting tool. And a ping is often called an echo request. So what you're doing is sending a packet out that says, hey, are you there at this address? And then there's a reply back. And I'm guessing that this also needs to be enabled in order for the ping to go through. I don't see other things that have to do with echo request, but echo is related to the ping, okay? So we have the ICMP echo, right, here, and that's for network diagnostics, and that should have done things. But then down here we have domain and private. All right, so let's see what happens when we try to repeat this command. No. Yeah, that is still pretty interesting here. I guess there could be an awful lot of stuff that's happening because of this. I'm looking for a plain rule here that would allow me to just open this up again. Remote manage, that has to do with a firewall. I'm not missing anything. Might require like a service restart or reboot or something. Ordinarily, the changes that I made would do the trick, and it would work just fine. Now, on a lark, I'm going to do this. I'm also going to enable IPv6, even though I'm not running IPv6. Maybe that will help. Okay. Yeah, let's try it one more time again. Nope, no difference. There's something else in there that was added for security updates. Let's just turn this whole thing off and see if we can duplicate our results. So if I turn off the firewall altogether, and then try it again. Okay, there we go. Yeah. All right, so there's a little bit of legwork I need to do on the sideline to figure out why this isn't working normally, but again, it could be because of security. There's a lot of slow stuff happening on our networks. There's a lot of disruptions and call drops. I think that has a lot to do with the global conflict that's spilling over into cyber. In any case, for the time being, if we leave this open so that this host can respond, so that this host virtual system can respond, and we run this command, we run path ping -4, and then we put in the 146.226.249.101. So let's do that now. Path ping -4 146.226.249.101. Is everybody with me?
Yes.
Okay. I could redirect this to a text file to capture it so that I have a copy of my output, but I want to see it first. So I'm just going to hit enter. And it starts the process, and it starts to trace all the different network segments that it has to travel before it gets to where? 101, sitting on the campus. Okay. And what I wanted you to do was to experience by issuing these commands. Okay, how many different network segments am I engaging just to go from where? I'm sitting in my home office connected with broadband VI. I'm using this command to see what kind of networks sit between here and the campus, which is 7 miles away. So my home office is 7 miles away from the UVI campus. I go to the first thing that happens is that I end up on the local network, right? I end up on a local network, internal. Then it's translated into a public network, 10.104.40.1. I could go here and I could say, okay, I want to know who 10.104.40.1 is. So I go to 10. What was it? 104.40.1. And I just want to look up something. I want to find out who that is. Who is, right? So this thing, this resource wants to make sure I'm not a robot. I have to select all of the squares that have to do with traffic lights. It's going to give me and it says, where am I going? Wow. So the 10 dot address must be internal, right? It's private. Everybody remember private?
Yes.
Okay. So I said I was using broadband VI. So broadband VI breaks up their service connections into smaller 192.168 networks, and then eventually they dump them all into a bigger private network. And then if I were to search 208.84.198.29, I'd probably see this broadband VI. That's the public side of the network. And then Miami is level 3, right? So what are we saying? This goes all the way out through broadband to Miami and then back through Miami to get to UVI, which is just 7 miles away. Now, what's the point? Well, there's a lot of different ways to connect from one location to another. And depending on how your networks are connected and how they're segmented, some of your digital packets on a network may travel some interesting routes. But one thing I wanted you to get a feel for are how many different segmented networks a connection goes through. Now, this is just a very simple, hey, I'm in my home office, 7 miles away is UVI, and I just want to reach out and touch my UVI machine 7 miles down the road. And this is all the stuff that happens in between, okay? Now it's sitting here blinking, and I can hit enter, and it's going to stop if I hit enter, or if I use Control C to break it. Sometimes you got to use Control C. This is what happens when the host machine is capable of responding the whole way. Now let's see what happens when we turn on our firewall, right? So let's say I turn on the firewall. And I run the same command again. So let's say that you have network equipment between here and your destination host, right? My destination host is the machine that's sitting in my UVI office, right? If I have network security equipment between here and there, then that network security equipment, even if it's as simple as a firewall, it's going to halt the progress of this command, but at least you get some information. Now, what I wanted you to do was to grab this screen, right? I wanted you to grab the screen that you had and then capture a screenshot. So that's what I'm going to do. I'm going to use the Alt Print Screen command. I'm going to open up a Word document. And this is just my own habit. Can everybody see my screen?
Yes.
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 There.
Yes.
Now, if you get a partial result, that's fine. You still get credit. It tells me that, okay, somebody has a firewall going somewhere, but at least you start to get some initial information about the nearby network segments, right? Let's click over here and hit enter. So our cursor's down here. I'm going to repeat the same command. Instead of using path ping, we'll use the next one, trace RT. There's a -H-4 and then the same kind of thing. So I'm going to do this, press Control C again, so I get my screen back. And I'll hit my up arrow key. That number is the same. I'm using my left arrow. I'm going to put a -H in there with a space. And instead of using path ping, I'm going to use trace RT. When I hit this one, wait a minute.
Yeah, that's what it gave me too. When I removed the H, it worked, I think.
It
if I
did,
can remember
but
correctly.
that H keeps saying it was like a bad value.
Well, that H used to be an option some time ago. And my apologies for the confusion. So let's try that. Let's do this. Ah. So are we supposed to put like max hops after? And then -4 forces the use of IPv4. So let's see. I'm going to put a colon and then like 20 after that. So the command may have changed a little bit. -H, let's try this. 20. And then -4, and then 146.226.249.101. No, it doesn't like that. Let's just try a space 20. Oh, hey. Okay, all right. Now, I'm telling you this with all the sincerity in my heart. I have videos from former classes, but in previous seasons, what's happened is that some of these commands have changed, some of the options have changed. And sometimes you have to do a little bit of research. Notice that traceroute is giving you some more information, but it's also running into some issues along the way, right? Not just in one place, and it says, oh, request timed out. So there's a certain amount of time interval that's standard. I think there's another criteria you can adjust to increase the default timeout so that you can actually wait longer to try to get through. But this is actually pretty interesting stuff, right? And what we want you to do when you get to the end of this is to do the same kind of thing. Just capture what you have, right? So if you capture this and then submit this document, you have the results of your path ping. I want to see what kind of network segments are in your neighborhood, and I wanted you to see what kind of network segments were in your neighborhood. That
It's gonna mean that can talk. May I share my screen with you, please?
Absolutely. Okay. So let me do one more thing first, though, before we forget. Okay.
Okay.
Let's adjust this. And once again, my apologies. I did not know that the command had changed. The options had changed. There was a time where this worked just fine. I'm going to put, so the max number of hops, let's put the max number of hops to be, let's keep it sane. Why don't we say 16? Because we're only going from your home to the campus, right? Okay. Now, sometimes it takes a few minutes to complete. You have to wait until you get the prompt back. And if you don't get the prompt back, let's say if prompt does not return after, well, let's say 3 minutes, okay? Press Control C. Everybody knows that you're holding down the control button and then hitting C, yes?
Yeah.
Okay,
Yes.
okay. I'm gonna stop sharing and then go ahead and share your screen, Anthony. LeQuinn, Mr. Anthony.
Okay. Hold on.
And are there any other questions?
Wait. Hold on. Quick.
Oh, no, I just thought while we were waiting for your screen.
Yeah. I'm sharing it. Wait.
So a quick thing, Professor. So the segments would be like we'd be counting from the numbers that are there on the command prompt, right? Just like whatever it says, like from 1 to 10 or 1 to.
This is
That'd be the
okay,
segment?
This is what I have now.
Pretty much. Yeah. Okay. So what I want you to do, that's what you have now.
Mm-hmm.
Okay. Can I ask you to do it one more time, but this time use the 101 instead of the 120?
Okay.
So just select the picture and then hit the delete key. Sorry about that. That noise will go away in just a minute. All right. If you minimize your screen and then share your command prompt, if you hit the up arrow key and just use 101 instead of 120, you should get more information then. Okay. And to answer the other question, who was that? Was that Kevin or James? Well, who asked the question about number of hops, number of segments?
I think it was James.
Okay. Yeah, basically, the number of separate entries would tend to indicate the number of separate network components the packet has to go through. And in some cases, it could be that it's working through a gateway. So you can get like related entries. You'll see a 192.168 1 dot something, and then you'll see a 192.168.85. I'm using a virtual machine. There's a virtual interface between the physical interface and the virtual interface. It is not technically, wow. Okay. Well, that's not giving you a whole lot of information. Now here's what could be happening. Your internet service provider and its connected equipment may have security turned on that doesn't allow you to perform this. right?
Yes.
Go ahead and submit this. And then,
With 11120 or 101.
with 101, and then try the trace route command. So, you know, just
Okay.
just
Same thing is happening to me.
yeah, if your service provider is blocking that kind of diagnostic, it could be that they're trying to prevent hackers from
Mm-hmm.
from
Facts.
performing reconnaissance on your network, right? So,
Mhm.
so that's one of the things that network security devices can do.
Must be via.
It's also possible that yeah, it could be Via could have a filter on that says, yeah, I don't care if you turn off your firewall, we have another one in the background. But the goal of the assignment was to give you a glimpse of all of the different network segments that are stitched together even in a short distance. Okay.
Okay, so first say use the 1 tree.
Yeah, use the trace RT.
Okay.
You can copy and paste that one. Now,
Mhm.
remember I said you can capture the output of the commands to a text file. And as an alternative, you can submit your text file. So you can do screenshots of your results,
Mhm.
or you can use the redirect and push it to a text file and then just upload the 2 text files if you prefer to do that. That's really a good practice, because then whatever output a command creates, it's like you've captured a copy of it. It's not just on your screen until you close the screen. See, this information is only it's only going to exist as long as LeQuinn has his command prompt open. But the moment he closes his command prompt, the IO buffer is emptied and this information is lost. So if he does, you know, an up arrow and then a space and then a right angle bracket, then another space, and then he puts down C:\temp/ pathping.txt, right? Then whatever is generated is going to get pushed to that file, and then he has it for future reference. So if you use your right mouse button,
Wait. I am typing in because it didn't work.
yeah, if you copy it off of a web page, you want to put a 20 after that, or a 16.
Okay, put on 101 or 120.
Put a 16 between the -H and the -4. Use your left arrow.
Mm.
Yeah, right. There you go. Yeah, that's right. There you go. 101. Right. Does this help? Does this help everyone? Yeah.
Yes.
Wow.
Yeah, it does.
Now, yeah, Via may have some different security measures. Oh, all right. So there's something there.
Mhm.
Oh, look. Okay.
That's cool.
Yeah, it is. So this is precisely why we will often use more than one command or more than one utility to perform diagnostics, right?
Mhm.
And what does that tell you? It tells you that the way that path ping works using ping echo requests is slightly different than what trace RT does. Okay. And trace RT is going to let you, now here's a bad, all right, so here's something you don't ever want to see. I got to capture this screen because this is perfect. Oh my gosh. So we have a separate course for systems security. And LeQuinn, I want you to capture this screen and then email it to me, because I'm going to post additional credit for you. And I'll do this for anyone else. Okay. Anyone anyone else that discovers this, LeQuinn, you see the fourth entry down that goes 10 something?
Which one? 10, you mean 10, 10, 10,
Look at
10
line,
with the one
not the,
asterisk?
not the line, but the line 5. Look at line 5 and look at the IP address.
Yeah, I'm seeing it now.
Okay, so what's supposed to happen is that you go from a private network out on the public network, and then your packet travels across public networks. And then when it gets on the other side back to the campus, to UVI, that becomes a semi-private network again, because they have firewalls in place and they try to, improve security. What you should never see is private, public, private, public, private, public. You should never see it alternate like that. Line 5 shows that part of the network segment between internet service providers, and this is somewhere in the Miami neighborhood, there's some network equipment and it's exposed, because you can see that it's an internal network. What we should see instead is a request timed out. Internal private networks are not supposed to show to the outside world, except for the beginning and end of this command. So if I were a network security guy, I'd be calling somebody in Miami, and it could be via, it could be level 3, and I'd be saying something like, hey, did you know that you have a private internal 10 network that's showing, we can look at it and we can get information from it while we're noodling on the internet, and that's not good, right? That's a really cool discovery. So another reason for doing this activity is to witness the very thing that we all just witnessed, is that you discover along the path from one host to another that there could be some network equipment that is not configured in a best manner. When we say best manner, we mean according to best practices. Again, we have a lot of security updates and changes that are in play right now because of the things that are going on in the world. But normally you're supposed to see a very consistent picture. And when you see differences, that begs the question and presents the opportunity to ask, why are we seeing this? Why are we seeing a private internal network? From point A to point B, it's all supposed to be public, 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 public. I should not see another private network in the mix, except for the very beginning and the very end.
It's gonna mean that Kenta, am I done with this?
Yes.
Okay.
Yeah. Yeah, that's
Okay.
yeah, actually you can just submit that, because you have both results right there. So all you got to do is save and then submit that as it is, and you're done. Okay, because you did the first command, didn't generate much. Got the second command, I got some very interesting results, but you were able to capture the whole command prompt environment in one screenshot that you could paste into a single document, so single image. Any questions before we clear for the day? Okay, if you would, go ahead and finish assignment 3.1, and then have a look at 3.2, and we'll see you in class on Wednesday.
You mean Friday?
Friday, Dr. Cato.
Yeah, Friday, not Wednesday. Today is Wednesday.
Oh, yeah, I knew that. I was just testing you. I probably need another cup of coffee. Okay. All right, then. Friday. We'll see you Friday.